Hello dear friends, welcome my channels. Today's discussions is based on linear algebra. So friends, you see that the matrix is A equals to -3, 2, -1, 0. And if we add these two element, then we get +1. Sorry, not +1. It is, the value is -1. And if we add this, then we get -1. So eigenvalue, one of eigenvalue is -1. One of eigenvalue is -1. And so friends, A cube eigenvalue of A cube is equal to -1 whole cube is equal to -1. So we have to, let's check where we can get eigenvalue -1. Then 309a plus 104i. The process is very large, you see, but if we use technique, then we can solve easily. So let's check that addition is -1 or not. So 309 -3, 2, -1, 0, and plus 109, 1, 0, 0, 1 equals to minus 927 plus 109 plus 618, that does not equals to -1 if we adding the row element, this element and this element, if we add, then we will not get -1. Now let's check another problem, that (511) -3, 2, -1, 0, plus 155, 1, 0, 1 equals to, if we add the column, so we can get -1533, this portion and this portion, plus, and this portion I multiply 511 plus how much is 1022 plus 155, and let's check that this addition should be -1, and let's see 1533 plus 1177. So 510, sorry, it is the second option I check. Yeah, I check second options, so it is 510, so it is 510. So I get 1532 equals to -1. Similarly, you can see that here I get 511 minus 511 plus 510 equals to -1. So eigenvalue, so we can get eigenvalue. In this case, we get eigenvalue is this combination. We get eigenvalue is -1. But if you see others problem, we do not get the eigenvalue is -1. So my answer is B. This is my answer. So next, if you see that minimal polynomial and characteristic polynomial are corresponding these two values. These two values is corresponding, two values are minimal and maximal. So CHA, I can write CHA is equal to lambda -1 and lambda plus 1 to the power 4 and lambda plus 1 to the power lambda -2 whole to the power 5. This is the CHA, and another value is minimal polynomial. So min A equals to minimal polynomial is equal to lambda -1 lambda plus 1 into lambda -2. So it is diagonalizable. It is diagonalizable. How? Because we know that it is the linear factor. This factor is linear. This factor is linear factor. This factor is linear factor. So if it is linear factor, so AM is equal to GM, as it is diagonalizable. Diagonalizable means AM equals to GM. So if you see the rank of A plus I, GM equals to GM of -1 is equal to N. Here N is equal to 10. 10 minus rho into A plus 1 I, and AM equals to AM minus 1 equals to 4. So this value is 4. 4 is equal to 10 into rho into A plus I equals to rho A plus I e plus I is equal to 10 minus 4 is equal to 6. So friends, my answer is in here 6. Now I will solve another problem. Problem number 3. The problem is that linearly independent x is equal to x1, x2, x3, y1, y2, y3 be linearly independent. B tail equals to this x2, y3 and y2, y3 and z to a del 3, and v, the value v, which is span of x comma y. Find the value of v. Let v equals to uvw. So as that is the span of x comma y, so you can write uvw x1, x2, x3, y1, y2, y3. So you will see that x2, y3, x3, y2 into u minus v into x1, y3 into y1, x3 and w equals to x1, y2 and x2, y1. So it can be written this way, friends. Del 1 u minus del 2 and del 3 w. So this is my v. V value is v equals to uvw such that del 1 u minus del 2 v plus del 3 w. This is my linear span. So equals to 0. As it is linearly span, so it is, you have to remember, as it is li, linearly independent, but it is dependent, so this value is 0. Now we will solve another problem, that is space of solutions. Space of solution of Ax is equal to 0. You see that the row space of 20 into 50 matrix A has dimension 13, and what is dimension of space solution Ax equals to 0. So how can I solve this type of problem? You will see that dimension is dimension of A equals to 50 because T such that r to the power n tends to r to the power m, where m cross n is column, n is 50 and m is here 20. So T such that r to the power n tends to r to the power m, here the dimension of row space, here dimension of row space E, dimension of row space E equals to 13, that is equals to 13, that means it is rank of A. So rank of A is equal to 13. So whatever you get the rank nullity. You use rank nullity theorem. What is the rank nullity theorem? Rank nullity theorem is that dimension of A is equal to rank of A plus nullity A. So rank of A is equal to 13 and dimension is 50 and nullity A plus nullity NA is equal to 13. So that implies NA is equal to 50 minus 13 is equal to 37. So my answer is 37. Now we will solve another problem. Problem is number 5. 5 number problem is very easy, that A and B is n cross n matrix. A n cross n matrix and B n cross n matrix, and you see that I have to find out trace of A square into B square. Now the rules of that: trace of A plus trace of B is equal to trace of A plus B. This is the one property. Another property is trace of AB equals to trace of BA, means it's follow commutative. It is follow commutative rule. So whatever you see, that if it is follow commutative rule, and now trace of A square into B square can be written trace of A B, take it is A as a x and it is y. So just I commutate trace of B A dot A B. This is the formula, friends, and it can be written this way. trace of b square into b. So my answer should be number 2 is my option is correct, ab square. Let's start to solve another problem is linear transformation. Linear transformation T such that r cube tends to r square and f x y z equals to 4 divided by x plus y. So you can say that it is constant term. Constant term. So as it is constant term, so it is never be a linear transformation. It cannot hold linear transformations. Why, friends? Because if I will multiply alpha into 4 and beta plus 4, it cannot show this property is linear transformation formula is LT formula. What is the LT formula? Our LT formula is T alpha f1 plus beta f2 equals to alpha T f1 plus beta T f2. So if you will see that alpha x1 y1, so it cannot be possible. So this is a constant term. So always remember, as constant term, so no linear transformations. As product terms, this term is product, so it cannot be linear transformation. So I cut this. Let's go number C. C is, you will see that it is not product, not constant term, so it is linear transformation. But I will check in here my I am correct or not. You will see, if I will multiply this way, f1 means z1 minus x1 plus y1 plus beta into z2 minus x2 divided by x2 plus y2. So it can be written this way: T alpha x1 it can be written this way: T alpha z1 minus alpha x1 plus beta z2 minus beta x2 divided by oh sorry, this is the I am working wrong. Sorry friends, there is some wrong is in here. It is very simple. It is this way: alpha 1 is equal to x1, y1 and z1, and beta is equal to x2, y2 and z2, and alpha T f1 and t is equal to alpha x1 alpha x2, sorry, it is beta x2 alpha y1 plus beta y2 alpha z1 plus beta z2. This portion is equals to it can be written this way, that alpha z1 minus x1 plus beta z2 minus x2 and alpha x1 minus y1 plus beta x2 plus y2. So I can write this way, alpha z1 minus x1 divided by here is also one portion is wrong. This is this way it can be written, not divided by x1 plus y1 plus beta z2 minus x2 plus y2 and equals to alpha t x1 y1 z1 plus beta t x2 y2 and z2. So we will establish that it is linear factorizations, linear factor. Now we will solve number 7. Let V be the vector space and polynomials of less than equals to 10, and let Tpx is equal to P dash x for P belongs to a V linear transformation V to V, and consider the basis 1 x and dot 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 up to this x square x cube of V x to the power 10, and T is the basis. So friends, whatever you see, problem is very easy, it's not very tough. You will see that, and then the following questions: the trace of A is equal to 1, and number 2 date A equals to 0, A has no eigenvalue. This is the MCQ type questions, friends. and you see that let A be a matrix of T with respect to the basis. So how can I solve this problem? Number one, V is equal to P10 x and T Px is equal to P dash x. Tpx is equal to P dash x. And our basis, it is consider the basis. Basis is also given 1 comma x comma n. So b is equal to 1 x comma x square comma x to the power 10. So friends, b is equal to x to the power 10. So we see t1. Let's put t1 is equal to 0 into 1 plus 0 into x, as t dash x is equal to 1. 0 into x plus 0 into x square up to 0 plus 0 into x to the power 10. Similarly, t x is equal to 0 into 1 plus 1 plus 0 into x square plus 0 into x to the power 10. T x to the power 10 equal to 0 into 1 plus 0 into 1 plus dot 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 plus 9 into x to the power n plus 0 into x to the power 10. This is our vector, our basis. Now I have to find out the basis. So A is equal to whatever I get. A is equal to it can be written is column wise. So I write 0 0 up to 0. So it is 10 10 10 10 10. So it's not 10, it is 11, because 0 0 0 0 up to x to the power 10. After that, vector is, next vector is 0. This portion is not 0, this portion is 1 plus x plus up to this. So zero 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 and up to 0. Then it value is 0. Then it is, the value is 2 up to 0. It is 0 0. It is 3 up to 0. So whatever we see, we see 0. We see 0. Up to 9 and 0, and this is the total portion 10 cross 11 cross 11 matrix. I hope so, because total base is 11. So 11 cross 11 matrix, and you see that this is different, and eigenvalue is 0. Eigenvalue is 0. So my determinant values is, dead value is obviously 0. This portion is 100% correct. Now we see another options. Trace of A equal to 1. This is totally wrong. and number 2, and A has non-eigenvalue. A has it is non-zero eigenvalue. Question is non-zero eigenvalue, so it is also wrong. And another problem is it is not correctly written, that is given into a to the power m equals to 0 such that there is no m comma n m belongs to a capital N. So friends, this is the totally wrong, because you see that we get at least some values, because where we can get, this is the nilpotent matrix, so we can get values easily, that where a to the power m equals to 0. So now we will solve another problem. T such that r to the power n be a linear map that satisfies t square is equal to t into in, and then which of the following is true? Number 1, t is invertible, t minus in is not invertible, and t has real eigenvalue, and t cube is equal to minus in. Let's start to solve this problem. So friends, whatever you see that t square is equal to t minus in. The problem is t to the power t such that r to the power n tends to r to the power n. The problem is t such that r to the power n tends to r to the power n. We begin n equals to, we take n equals to 2. So t square is equal to t minus in. So our values is lambda square is equal to lambda minus 1, and we see that lambda is equal to, it can be written this way, lambda square minus lambda plus 1 equals to 0. So it can be written half plus minus root over 3 by 2 I, and this is the example is a is equal to, very simple example, a is equal to 0 minus 1 1 1, this type of matrix, because you will see that a minus lambda I equal can be written minus lambda 1 and minus 1 and 1 minus lambda, counter example. So you will see that it is minus lambda plus lambda square plus 1. This is my characteristic equation, equals to 0 is my characteristic equation, ch lambda. This is my characteristic equations. So we check this matrix. I have to choose a counter examples. So t does not have a real eigenvalue for n equals to 2. So t has a real eigenvalue. This portion is wrong, friends. T does not have real when n equals to 2. So t does not have real eigenvalues. So this is the first option. Third option is correct and wrong. Another portion is t is invertible. T is invertible, friends. As date of A equals to, in here you will see 1, so t is invertible, and t minus in is not invertible. If we see t minus in, so lambda value is, so eigenvalue t minus eigenvalues is lambda minus 1, and lambda minus 1 is half into plus minus 1 root 3 by 2 I equal to, it may be this value is minus and minus 1. I can write minus 1. It can be written minus half plus minus root 3 by 2 I. So friends, we see that eigenvalue is not 0, so t minus I is invertible, as we see that eigenvalue is no 0. In the case of n equal to 2, and the factor number 4, t cube is equal to minus in. Now let's see that t cube plus in is equal to t plus in into t square minus t plus in, and this portion is 0, so it is t minus in into 0 equal to 0. So whatever we get t cube is equal to minus in. So this portion is also correct. Linear algebra is the very important and very conceptual. Next problem is number 9. Number 9 is very good problem. M is equal to, m is given, m equals to 1, 2, minus 2, minus 1, 1, 1, 1, 4, minus 4. This is the m values. Now I have to find out that given that 1 is an eigenvalue of m, then which among the following are correct? 1 is one eigenvalue, 1 lambda 1 is equal to 1, and lambda 2 I don't know, lambda 3 I don't know. So lambda 1 plus lambda 2 plus lambda 3 equals to 1 minus 4 equals to minus 2, and you will see that lambda 1 equals to 1, 1 plus lambda 2 plus lambda 3 equals to minus 2, and lambda 2 plus lambda 3 equals to minus 3. So friends, another factor is lambda 1, lambda 2 and lambda 3, because trace is that sum of the lambda 1 is equal to lambda 2 plus lambda 3 is equal to trace of A. This is the property of eigenvalue. Lambda 1 into lambda 2 is equal to minus 4 plus minus 8 plus 8 plus 2 plus 2. So this value is 8 plus 0 plus 4 equals to minus 4. So this is my total value, and lambda 2, so lambda 2 lambda 3 is equal to minus 4, because as lambda 1 equals to 1, lambda 1 equals to 1, remember this. So I have to find out lambda 2 and lambda 3. So my problem is, this is the lambda square minus minus 3, it is the x square minus 3x minus 4 equals to 0. So we can get a quadratic equation. So this equation I will solve. Minus 4 plus 1 x minus 4 equals to 0, and x minus 4 equals to 0. So I get the value x is equal to minus 1 and x minus 4. So lambda 2 is equal to minus 1 and lambda 3 is equal to 4. So this is my total values. So friends, there is one mistake in here. It is minus 1. So it is plus 4, and it is plus 4, and it is minus. So it is plus 1, it is minus 4. So my lambda value is 1 minus 4, it is 1, and it is 4. So the characteristic M equals to lambda minus 1 whole square into lambda minus 4. Now my question is the minimal polynomial. What is minimal polynomial? Minimal polynomial of a matrix M is a monic polynomial. Minimal polynomial equals to monic polynomial. Monic polynomial and monic polynomial of smallest degree So friends, if you test the minimal polynomial, then whatever you see, minimal polynomial of minimal polynomial poly is equal to m. So let's take that m minus 1 and m minus m plus 4. If we putting this value, then we do not get, it is 0. So only one possible, that m minus 1 whole square into m plus 4 equals to 0. You will check this portion, as the time is very short, so I can't teach the total calculation. However, calculation is very important part. So whatever I get number 2 is the correct and number 1 is wrong. I just give idea friends. And m is not diagonalizable. This portion is also correct. This portion is also correct because you see that minimal polynomial is mean of m. Minimal polynomial is equal to lambda minus 1 whole square into lambda plus 4. As lambda is equal to, you can put in here m. However, this is not linear factor. If it is linear factor, then it is diagonalizable, but it is not diagonalizable as it is not linear factor. So m is not diagonalizable. And number 3, now our characteristic equation is if you see that characteristic equation phi x is equal to lambda x minus 1 whole square into x plus 4. So friends, if you see that in here, you can get m inverse is equal to 1 by 4 into minus m square minus 2m plus 7i. So this portion is also wrong. You cannot get from this because it is cube term. Now next problem is number 10. Number 10 is very interesting. That characteristic polynomial of a is equal to lambda minus 1 whole cube. So this type of problem, we take example. This example is very we take this example 1 0 0 1 1 1 1 0 0 1. this type of problem, you will see that all the eigenvalues is 1, so it's follow these equations, friends. So it is the example. I take example. Now A is necessarily diagonalizable. I have to see it is necessarily diagonalizable or not. It is correct or not. So what is diagonalizable? Question number 1, that what is diagonalizable? Diagonalizable means AM equals to GM. Then it is diagonalizable. AM equals to GM. Now you have to see that it is AM equals to GM or not. So A minus lambda ix equals to 0. So A minus lambda I so whatever we get here, lambda equals to 1, so I have to find out this equation. So whatever I get this equation is 0 0 0 1 0 0 1 1 0. I can get these equations. And another equation is xy z equals to 0. So we get z belongs to R and x equals to 0 and y equals to 0 from these equations. So our x is, we can get only one eigenvalue, that is 0 0 1, and algebraic multiplicity this is called AM. Whatever we get AM value is 3 as the, and GM value is GM is equal to GM of lambda 1 is equal to n minus rho into A minus I, and we get n equals to 3 minus 2 equals to 1. So we do not see AM does not equals to GM. So it can be easily proved that it is necessarily diagonalizable. This idea is totally wrong. This is wrong. If the minimal polynomial, next question, if the minimal polynomial of A lambda minus 1 whole cube, then A is diagonalizable. Now this is also totally wrong. This is also wrong because lambda minus 1 whole cube is not linear factor. We need that minimal polynomial should be linear factor. So A is not diagonalizable. This portion is wrong. Number 3. Characterizations polynomial of A square is lambda minus 1 whole cube. Lambda minus 1 characterizations polynomial of A square is equal to lambda minus 1 whole cube. Next problem. So friends, you see that a square and a is equal to a is lambda 1, lambda 2, lambda 3. So a square eigenvalue is also lambda 1 square, lambda 2 square and lambda 3 square. So if lambda 1 equals to 1, it is equals to 1, it is equals to 1. So you see that it is also 1. It is whole cube, not just whole square. This is 1 and this is 1. So whatever you get, this is the 1 1 1 and 1 1 1. So a minus a square characteristic equation, ch characteristic equation of a square is also lambda minus 1 whole cube. So this option is 100% correct. This is correct, true. This is true, this is false, and this is also false. Next, if A has exactly 2 Jordan block, okay, this is the must remember, 2 Jordan block. So A minus I whole square is diagonalizable. Simple friends, if A has 2 Jordan block, so the possibility is 1 0 0 1 1 0 1 0 0. This is one possibility, and another possibility is A equals to 1 1 0 1 and 0 0 1 0. This is a total two possibilities. Two possibilities. This is the two possibilities. So friends, whatever you see, that if the possibility is 2, so A minus I, whatever the problem, A minus I will be, if you see A minus I, then the matrix should be 0 0 0 0 0 1 0 0 0. And another possibility is A minus I, that is 0 0 it will be 0 1 0 0 0 0 0 0 0 0. So friends, if you square, in both case it is, if you square, this is the nilpotent matrix. So A minus I is nilpotent. So if you square this, so you get 0 in both case, and 0 means this is the 0. So friends, we know that this is diagonalizable. This portion is diagonalizable. So my answer is number 4 is correct. So this is my true answer. Thanks for watching.